This video, I said I have another interesting topic I learned again last week at Blockfuse Lab, and that is how private keys, public keys, and Ethereum addresses are generated. So I posted this on my ArkMD account, so you guys can check it out at the URL here. Sorry, currently I'm unable to post links in my YouTube video. As time goes by, I'm going to verify that so that you guys can have easy access to materials that I use. Okay, so I'm going to be putting us through how private keys, public keys, and Ethereum addresses are generated. Let's start from understanding where your funds are stored. Did you know that your funds aren't actually stored in your wallet? All your assets, such as Ether, are stored on the blockchain. So when you open your wallet address, let's say MetaMask, for example, and you see that, oh, I have 20 ETH, I have 50 ETH, you're happy, you be like, oh wow, this is nice, I have money, I'm rich. Yes, you are. But the actual money is not in that wallet you are seeing. It is on the blockchain. Your money, your funds are on the what? On the blockchain. So what the wallet does is just an interface that helps you interact with the blockchain. Okay, so that is basically what a wallet does. So let's go to what is a wallet. A wallet is a software that serves as a primary user interface for interacting with Ethereum. Think of a wallet as a safe where you keep your valuables. Exactly. Just think of a wallet as a safe where you have your things. Okay, let's say you keep your documents and stuff. In the world of blockchain, these valuables are your key pairs, which are your public and private keys. So what your wallet is doing is to just help you house your public and private keys, which are then used for transactions or for what? For communicating with the Ethereum blockchain, which is where your funds are actually stored. Okay. So now, to understand public and private keys, let's use a bank account as an analogy. When you create a bank account, you receive an account number and a PIN. The account number is like your public key, something you can share with others. Of course, that's true. That's what you share with others to receive transactions. While the PIN is like your private key, something you must keep secret to authorize transactions. So when you share your address with others to send funds to you, what happens is that that address you are sharing is like your account number. When that fund is being sent, what it verifies, or even if you also want to send funds to other people, what authorizes your transaction is your private key. Okay, so the primary purpose of a wallet is to store these keys so that they can be used for transactions on the blockchains. Now, how are these keys generated? Okay, the generation of these keys is purely mathematical and follows a specific formula. However, just because there's a formula doesn't mean you can get someone else's private key. You know that, right? So don't start thinking, oh, once I know how private keys are generated, I'll look for a way to guess how to generate Elon Musk's Ethereum account private key, or I'll look for one rich man and look for a way to guess his Ethereum private key or whatever. No, it is not possible. The formula used are one way, meaning that they cannot be reversed. Okay, so I added an example. So, for example, multiplying two large prime numbers together is straightforward, right? Yes. But given the product of two large primes, it is very difficult to find the prime factors. Let's say I present the number 100,160,063, and I tell you that it's the product of two primes. Finding those two primes is much harder for you than it was for me to multiply them to produce 100,160,063. Okay, but this can be easily inverted. You know that, right? This is correct. Let me use a simpler, a lesser value. Okay, let's say I have let me say 7 and 5. 7 times 5 is 35. Okay, so let me say I have 35. I gave you 35, and I said, what are the two prime numbers that were multiplied to give 35? Well, that is quite simple. You might have guessed 7 times 5, right? Okay, but look at this case scenario whereby it is a very very big number, a very large number. So it becomes more difficult to be able to what to get that those two prime numbers. Okay, but it was easier for me to multiply two prime numbers and get this big value than it is for you to get the two prime numbers from the result. So it is a one-way thing. That is, it is easier to go forward, but very very difficult, almost impossible to come backward. This is very very simple analogy. Okay, so let's assume, but it becomes easier if I tell you that one of the prime factor is 10,007 here. If I give you this information, that means if I give you more information, you would be able to get the other prime factor of this number. Okay, so these are often called trapdoor functions. Why the whole concept of creating a secure function for securing information is regarded as cryptography. Okay, so cryptography simply means we are looking for a way to secure something, an information, a digital information. So that is what cryptography. Cryptography is just a form of what? Encryption on the blockchain. Okay, so now, which function do we then use to generate private and public keys? Since you know that private and public keys are very, very complex, you might have seen one before, public keys especially. Use your contract address, for example. You have a bunch of 0xFE21 concatenated together in a long string. So it is very, very difficult. So how are these generated? So a more advanced mathematical function called the elliptic curve cryptography is used to generate private keys. Elliptic curve cryptography works on the principle of elliptic curve arithmetic, which involves operations that are easy to perform but nearly impossible to reverse. This difficulty is known as the discrete logarithm problem. Now, what do we mean by this? In the first scenario I gave you here, above here, in the example I gave you here on top, where I say you multiply two, give me the two prime numbers I multiply to get this number. Okay, this is simple in a sense compared to the algorithm or the mathematical function used to generate private keys. If this were the case used to generate private keys, then it might be easier. If you have access to one of the prime number, you can actually get the private key. Okay, but then that is not the mathematical function that is used. The mathematical function used in generating private key is called the elliptic curve cryptography. This is mathematics. This is pure mathematics. So people that have a good knowledge of mathematics will actually enjoy this a lot. Okay, so now, how is the private key now generated using this elliptic curve cryptography? Okay, so it is done such that, look at it, to generate a private key, a large random number, typically 256 bits, is created using the ECC. Remember, ECC stands for what? Elliptic curve cryptography. Okay, so this number is validated to ensure it fits within the required range for the cryptographic system, such as the SEC P256K1 curve used in Ethereum. The result is the private key, a crucial piece of information that must be kept secret to secure your digital asset. Okay, so what this is saying is that whenever I want to generate a private key, look at it as a coin. A coin has two sides. Look, so to generate a private key, it's like tossing a coin 256 times. Can you look at how complex that is? That is. So when I toss the coin the first time, I record the head. The next time the tail. I keep recording till I have that 256 times. Then after getting that, I still validated it to make sure that it conforms to this SEC P256K1 curve used in Ethereum. This is also used in blockchain actually. Now, what is this complex SEC P256K1 wherever? Okay, it is simply a name actually. Okay, so the SEC 256 K1 is a specific elliptic curve used in cryptography, particularly in blockchain technologies like Bitcoin and Ethereum, to generate cryptographic keys. The name breaks down as follows. Okay, the SECP stands for what? Standards for efficient cryptography. And the 256 means a bit, a what? A 256 bit field size. That is, it has a size of what? 256 bytes. Okay, while the K1 indicates certain mathematical properties that makes the curve efficient and secure. Now, since we've seen how to generate public keys, how is public key generated? It is generated randomly. Okay, all right. So now, how do we then generate a public key? Once we generate a private key, actually, the most important information about your account is the private key. Don't forget that I liken private key and public key to what? To bank accounts and PIN and transaction PIN. Once your transaction PIN is compromised, what happens to your funds? They are all gone. Everything is gone. Okay, so your private key is very, very important, and it is advisable that you don't store it electronically. That is, don't store it inside Google Drives, don't store it inside screenshots, don't send to Gmail. They can be compromised. It is better you store them on hard disks. Store them on hard disk. But actually, wallets have actually made them easier for us nowadays, that we don't have to start memorizing private keys or writing down private keys. It is done in such a way that it is automatically stored on your device, and you are being given in some mnemonics. For example, when you create MetaMask account, you notice that MetaMask will tell you that, oh, your account has been created. So write down these words in a secured location so that nobody else have access to it. So those mnemonics are actually like keys to your private key. So they're just like passwords to your private key. So you don't see your own private key per se with your eyes. You don't see it. So it is also, it's like securing the private key itself. Okay, so it's a bit complicated, but then it's simple. The whole idea is simple. So the most important thing in your address or in your wallet is your private key. Once anyone have access to your private key, then they have access to all your funds, irrespective of how much you have. They have access to everything. So it is very, very advisable that you store your private key highly secure. Okay. So now, how do we then generate public keys? After once private keys has been generated, the private key is once the private key is generated, the public key is created by multiplying the private key. Okay, so let's say we give the private key small letter k by a predetermined point on the elliptic curve known as the generator point. Now, the generator point G, the result is another point on the curve, which is the public key. Now, look at the mathematical expression for that. Okay, so it is simply the relationship below. Look at it. Public key is equal to what? Public key capital K is equal to what? Private key times the what? The generator point. Okay, so let's assume that I have my private key to be this. You can see how long this is. So imagine having to write this down. Even having to write it down, you might make mistakes somewhere. Oh, probably your eyes keep the one C in this place. So that is why your private key are not always being displayed to you. Instead, we use mnemonics, which are like keys to what? To access your private key. Okay, so the formula used to generate public key is what? Multiplying K, which is the private key, by G, which is the generator point, on the elliptic curve. Okay, so let me show us a pictorial diagram of what the elliptic curve looks like. Okay, so here you can see this. Let's use this for example. See what the elliptic curves looks like. Okay, so what this means actually is that there's a point G on this curve. Okay, let me click one for example so we can use that. Okay, so now using this as an example, okay, so let's say point R is our private key and point Q is our generator point. Okay, so to generate the public key, what we do is to multiply R with Q. Now when we multiply R with Q, we get a result. The result we get is also a point on the elliptic curve. So let's say the result we got is another point P on the what? On the elliptic curve. So that is to tell us that both the private key and the public key, when you multiply the private key and with the generator point, you get what? The public key, which is also a point on the elliptic curve. Okay, I believe you have a better understanding of that now. Okay, so now let's go back to the post. Okay, so now we use the formula public key is equal to private key times the generator point, which is this, to get our what? Our public key. Now remember I said public key is also a point on the elliptic curve, and when from mathematical knowledge on a graph we have, which is the Cartesian plane, like what I showed you here. Cartesian plane in the sense that we have the x and y axis. So any point here has a coordinate called the x and y axis. That is, it is at a certain distance from the x axis and also at a certain distance from the y axis. So that is why we say that what? The public key k is equal to x comma y, where x and y are coordinates on the elliptic curve. Okay, now it is easy to generate a public key from a private key, because you might be looking at it that since this is the simple multiplication formula that I'm using to generate what? A public key from the what? The private key, by simply multiplying k and j. You might be looking at that, oh, then if I want to get the private key, then I should simply divide k, which is the public key, by what? By the generator point to get my private key. No, it's not that. So it is easy to generate a public key from a private key, but nearly impossible to do the reverse. The elliptic curve arithmetic is designed so that when you try to reverse the operation, that is, you want to do k, which is the public key, divided by the generator point g, you get many possible answers, which is equivalent to many points on the curve. Okay, so getting an answer which is exactly equal to the private key is a brute force search. What do I mean by brute force search? Brute force search simply means, okay, let's say since in this case we said we are going to get many answers. So that means out of the many answers, one is actually the private key, right? So when you say a brute force search, it's like you have to do all possible comparison. That is, you have to get all possible answers. Then you now start doing this calculation to get the exact one that you're looking for, which is nearly impossible. Imagine having millions of answers and you have to just guess one out of it. So that is what we call it was a brute force search. Okay, so now we've seen how private keys are generated. Private keys, once they are generated, all other generation, which include the public key and the Ethereum address, are generated based on the private key. So the private key, once again, is generated randomly, which is includes what a 256 bits, abi. Okay, so I will use the word elliptic curve cryptography to generate that. So once that is generated, that is the most difficult part. Once the private key is generated, then it becomes easier to generate the public key using this formula. Then how do we now generate the Ethereum address? Okay, so now generating the Ethereum address, okay, which is here. Finally, the Ethereum address is generated from the public key by passing it through the Kazakh 256 hash function and selecting the last 20 bytes of the hash. Let's break this down. This Kazakh you're seeing here is the name of a hash function. Now, what is a hash function? A hash function maps data of arbitrary size to data of fixed size. That is, for example, if you hash the word apple, you might get a string like this. You might get a string like this. Even if a small change like adding an s to make apples, it will produce a completely different hash. So if you make a change to apple and it becomes apples, the hash you are going to get, don't think, okay, maybe the one that is starting it will now start with 2 and every other thing will still remains the same. No, it does not work that way. You get entirely a new hash, which is going to be entirely different from this previous hash. So a small change to the input, okay, for those that have knowledge of programming before, when you have a function, for example in JavaScript, a function accepts something we call argument or parameters, okay, and it returns a result. Not all, in case depending on the kind of function you are creating. In this case now, what you input into the hash function is called the input data or the pre-image. Okay, that is the argument you pass into the hash function is called the pre-image, or it is called the what input data. Okay, and the result you get from the hash function is what we call the hash. So in this case now, where I'm passing apple into an hash function, this apple is called the pre-image or the input data, while the result I'm getting, which is this, is called the hash. Okay, so now for Ethereum address, Kizak 256 is the hash function used. So what we do to generate an Ethereum address, how Ethereum addresses are being generated is by what? By using this Kizak 256 hash function and passing the public address into it. Let's look at the example here. Okay, so let's assume that the public key is equal to this, and we do the Kazakh 256 hash. It gives us this. When we pass this was the hash that we got. When we pass this guy as the pre-image or the input data, we got this as the result. Okay, so what this last part means, which says that what we select the last 20 bytes of the hash, is this. It simply means that what the Ethereum address we select is what the last 20 bytes that comes from the back, from here. The last 20 bytes is what we regard as the Ethereum address. So if you look at it, that's from here to here. You can see that from here to here is what we have as the Ethereum address. So we neglect the first part, we select the last 20 bytes. Okay, now in most cases you notice that Ethereum addresses always start with 0x rather. Okay, now what this means is to indicate that what Ethereum addresses are hexadecimal encoded, and you often see them prefixed with what 0x. So when you have the Ethereum address like this, when you selected the last 20 bytes of the Kazakh hash function, okay, what you do is just what prefix it with what 0x, and that becomes our what Ethereum address. And that is simply how Ethereum address are being generated. Okay, so let's just have a overview of it again, like a summary of it. How do we generate Ethereum address, private keys and public keys. We say that private keys are generated using the what elliptic curve cryptography, which is what selecting the random numbers of 256 bytes. Okay, so let me just scroll down to where we have that so we can see that. Okay, of 256 bits. Okay, so we use the word elliptic curve what cryptography, and this number is validated using the what the SECP 256K1 curve used in Ethereum. Bitcoin also uses this also for the verification, and that is why most features in Bitcoin too, or most libraries in Bitcoin can be used on Ethereum too. Okay, and after we generated the what the private key, the next thing is to generate the public key. I already said that the public key can be generated from the private key by simply multiplying the private key by the what the generator point. Don't forget, the generator point is a point on the elliptic what curve, is a predetermined point on the elliptic curve. Okay, so after we generated the public key, what we just have to do to generate the Ethereum address is to pass the public key into an hash function, and the hash function in this case is the Kezak 256 hash function, which is the hash function used in Ethereum. Okay, so this hash function will take in the public address and return a hash for us. Then we then select the what the last 20 bits or the last 20 bytes of the what of the hash, which then gives us our Ethereum address. But then it's not done. What the last thing we just have to do is what prefix the what the last 20 bits of the hash function by what by 0x, which then makes up our what Ethereum address. So in conclusion, knowing how private keys, public keys, and Ethereum address are created is key to feeling confident in the world of blockchain. So that means that no someone can just come and start saying bullshit to you about the generation of public key and private key, or someone can just come to you and say, "Oh, please share me your private key. I want to send you some funds." You know that that is purely what scam. Okay, so these cryptographic tools are what keep your digital assets secure and ensure your transactions are safe. By understanding the basics, you not only protect your investments or funds, but also gain a deeper appreciation for the technology that powers cryptocurrency. These things are beautiful. I really, really enjoy it. I'm actually having fun at Blockfuse Lab. And thanks to Blockfuse Lab for this knowledge. I've really, really learned a lot, and I look forward to learning more this week again. So you also should look forward to hearing from me by the end of the week. And thank you very much. Goodbye. Do have a lovely day. Bye.